Welcome to this video about shift registers. In this video, we will cover what a shift register is and why and how shift registers can be used. First of all, what is a shift register? A shift register is an IC, so an integrated circuit, which implies that inside this little shift register is actually an entire circuit. To better understand any IC you encounter, you could follow these 6 steps, which are explained in more detail in another video. We start with identifying the IC. Suppose that we wish to consider the SN74HC595, which is one of the many shift registers available on the market. Now that we have chosen which exact shift register we wish to consider, we can move to the second step, getting the datasheet. We are going to need this when we dive into the details later on. But before we get into these details, we should ensure that we have a basic understanding of the shift register. So what can a shift register do? To illustrate this, let's consider the following example. You can think of the shift register as a sorting center for boxes. But rather than sorting actual boxes, it can sort data. For instance, the SN74HC595 can sort a series of bits into individual parallel bits. This kind of shift register is called a serial in, parallel out, or SIPO shift register. And this can help to reduce the amount of pins you need to use from your microcontroller. Apart from sorting data, the SN74HC595 can also store a little bit of data. To understand both main functions of the shift register a little bit better, we will need to dive into the details of the shift register. Let's have a look. The details of the shift register can be found in its datasheet, which shows information such as pin configuration, the input and output voltages, as well as the desired supply voltage, and the relation between inputs and outputs. In the datasheet, we can see that the SN74HC595 has 5 digital inputs, 9 digital outputs, a pin for the supply voltage, which is the VCC pin, and a ground pin. The digital block diagram of the datasheet shows that the inputs are related to the outputs according to a combination of logic gate and flip-flops with clocks. For instance, you can see the NOT gate and many flip-flops with clocks. To help you understand how the different input combinations relate to the output combinations, the datasheet also contains a timing diagram. Here you can see that when the SRCLK, so the shift register clock pin, receives a rising edge, so it goes from low to high, and the SER, so the serial input, is either high or low at that exact moment, then that bit, which can be a 1 or 0, is pushed into the shift register, and all existing bits move one place forward. Next, when the RCLK, so the storage register clock pin, goes high, the 8 bits that were shifted in are copied to the output latches. So the 8 output pins Q0 to Q7 all update at once to match the stored values. If the outputs of the 74HC595N are then used to drive LEDs, you can turn on or off any of the LEDs depending on whether the stored bits are zeros or ones. By changing when the SER is high or low during each shift clock pulse, you can control exactly which pattern of bits is stored, and thus which LEDs turn on and off. Think of it in this way. The shift register, so your package center, has 2 main actions. It can shift using SRCLK, and it can latch using RCLK. Shifting moves all the bits, so all the packages, whereas latching updates the outputs. So you can shift, latch, updating the outputs bit by bit, or you can shift, latch, making the entire input byte update all 8 outputs simultaneously. The three digital inputs of the shift register, the shift register clock, the storage register clock, and the serial input are typically controlled by a microcontroller. This way you can control both the outputs that you have, as well as the speed at which the outputs are being updated. And this is useful if you want to show the correct pattern of bits to light up the correct segments of a display, and to update these segments quickly enough for the number on the display to appear stable and smooth. Apart from the inputs and outputs mentioned before, there are a couple more, such as the VCC pin for the supply voltage, the ground pin, and a few more things. I will first discuss the remaining input pins and then cover one output pin in a bit more detail. The input pins that I did not discuss yet are the output enable pin and the overriding clear pin. As their name suggests, the output enable pin must be low for the outputs to be enabled, and the overriding clear pin can be used to clear the entire shift register. The latter implies that when overriding clear is held low, all the stored bits are reset to 0, and when it is high, the shift register works as normal. Finally, let's discuss the one final output pin, the QH asterisk pin. Because what if you don't want to have 8 outputs, but perhaps 9, or 10, or 24? Well, it is possible to chain multiple shift registers together. And this would be similar to expanding your sorting set. By connecting the QH asterisk output pin of one shift register to the serial input pin of another shift register, you can expand the amount of outputs that you have. This technique is called daisy chaining, and this allows you to pass signals from one shift register to the next shift register. Don't forget to connect both the shift register clock and the storage register clock between the shift registers as well. Okay, so we now know that the shift register can sort and store data, control multiple outputs, and be daisy chained with other shift registers to expand the number of outputs. This also allows you to use less of those precious output pins of your microcontroller. However, the shift register is not the only IC that can do this. Another way to do this is by using a BCD decoder, which will be discussed in a separate video. Make sure to watch that video as well. After watching the video about the BCD decoder, I will show you how you can combine BCD decoders and shift registers to drive multiple 7-segment displays, with only a few output pins from your microcontroller. And by doing so, you can truly unlock all the possibilities and functionalities you might have for your 7-segment displays. But for this time, this was a tiny register with huge control.